The second one that we look at is the task that you learned in class. So this one, the weighted interval scheduling. Okay, so you have n requests, and each request has the starting time and the ending time, and you have weights. This is like the interval scheduling problem when you can use greedy, but the greedy algorithms doesn't work when you have weights. So you need to do something else. Okay, so let's look at the problem quickly. Okay, so you have n requests. Okay, and each request I start at si and end at let's see, at ti. Okay, the task statement is incorrect here, sorry. So this should be ti less than or equal to ti plus 1. So the ending time is like sorted, has already sorted, and it has value wi. Okay. All right. So in this case, you cannot use greedy because there's a value here. Okay. So to get started, we need to recall. We need to come up with recurrence, and on that we need to deal with boundary condition. Okay, and also we need to implement the algorithm. And to implement the algorithms, there are two ways: either do that recursively with memorization, or you can do it with you can do it bottom up with iterations. You just do the for loops. Okay. So we will look at this first. Okay. We try to come up with the recurrent first. Okay. Typically, when we think about the recurrence, you need to think about the choices. Okay, what can you do, right? Choices. Okay, but there are many ways to start looking at choices. Either you can look at the first choice, or look at the last. Many times we look at the last because it'll give you a simpler recursive formulation, but you can look at the first choice as well. But yeah, both of these will be okay. But here we look at the last choice that we made. Okay, so there are n requests. You wanna schedule the request recursively. No, in such a way that you doesn't have any conflicts, and you want to maximize the weight. Okay, so but you know that the requests are sorted. It look like the last one, maybe like that. Sorted by the ending time. Okay, so larger value of the indexes go up like that. Okay, so if you look at the choice that you have to make, you want to pick a subset of requests, right? So the last, if you look at the request in turn, the last one that you look at will be the one with the largest index. So that's the n minus 1 1. This is the last one. Okay, and what choice can you make for the last one? How many choices can you make? Okay, what can you do with this? Okay, what can you do with this? If you think about it, let's think about it for a minute before you continue. My hint is like you can do two things. There are two options. All right. I hope you really think about it. So you can accept, you can take this, or you can reject it. Okay. So what can you do with it? Okay. So look at the last task. Okay. Look at the end request. Okay. What can you do with it? So you can either take it, or just leave it. Okay. So given that you leave it, let's look at this choice first. If you just leave it out, okay, what's the best way you can schedule the request? So if you leave it out, it's like you end up with only requests up to n-1, right? So the best way you can do it is like to schedule all this optimally. Okay. So but if you take it, if you take the end request, so it means like, okay, I'm taking this request, right? So every other request that are in conflict with it, with this, will be we have to be throw away, right? But then you end up with the first request. Let's say it's called pn. Okay, that is not in conflict with this the request that we took. Okay. Then the best way you can schedule it is like, okay, to schedule all the requests from 1 to pn optimally. Okay. So this sort of like this leave us with the same problem, right? Exactly the same problem. Okay. So this should hint us to define the recurrence like this. So you can see that this is what I call subproblem. So this is the kind of subproblem that we have. Okay. So the subproblem says, in you want to schedule in the first n-1 task optimally, or you want to schedule the first this task optimally. Okay. And when you, let me do the final remark, when you want to do this, you look at the last one, right? But this rule can be used with the end request, the ith request as well. So in general, okay. So you while you dealing with the ith task, suppose you have only ith task, and how you to do that optimally. Okay. So this would give the sub problem or subtask. Sub problem would say you wanted to schedule the first I request. Okay, optimally. Okay, from this sub problem you have then you have a recurrence variable. So let's say vi will be the not the number, right? The base, the maximum value you can get when scheduling requests 1 to up to I. Okay, first I request. Okay, so there are many ways to write the recurrence. So basically there are two choices, right? But which one gives you the maximum value? I don't know. So if you don't know which one, you would say I'll take the max. Okay. So the first way is like do this, like leave the I request out. Okay, just reject it. Or if you want to take it, then you get WI. So from request I, right? But then you need to schedule the rest optimally. So let's call this PI, where PI is the index of first request, not in conflict with the I task. So the first one without that's is before, that ends before the I task starts. Okay. So to implement this, you need to get PI correctly. So let me call this PI. Okay. All right. Okay. This is a recurrence, and we need to also think about the initial value. So if we have v0 no task, then you get this to be 0. Okay. Now, to implement the C++ solutions, there's a few things that you need to be concerned. So here we start with the index number 1. So you need to think about it, right? When you write the C++ code, the index will start with 0. So the initial value will be a little bit harder to implement. So we would usually actually use either use the value of I to be starting from 1, so that we can have this. Okay. All right, so let's write some code. Okay, before we do that, you can do that in recursive fashions, but you can also do it in iterative way. You can see that when we want to compute vi, so in the end we're gonna have an array, right? So let's call it v. When you want to compute vi, you need to, if you know the value of everything before it, right? So because it need vi minus 1 and vpi, which should be less than I. So if you know everything about this region, then you can compute this instantly. Okay, so instead of having to write a recursive function, we can have an iterative function that goes this way. Okay, so you want to compute it bottom up, in the bottom up fashion. So this is the way you can do it. Okay, so you start by compute v0 and then use that to compute v1 and so on. Okay, so no need to write a recursive function. So let's write some code. No, the task doesn't have the limits on n. This is a bad task statement. It's my task statement. So let's see. I think it's just 1,000 maybe. So let's try to write it with maybe 5,000 first. Okay, to see if it actually work or not. Okay, and then we need to read the input. Again, I'm gonna keep the index of the value to start at 1, so that thing would be easier when I actually write the recurrence. So this is how I'm gonna do it. So let's see, but it start from 1 now. Okay, and then I say s0 equals t0 equals minus 1, just to be clear. And then the weight maybe 0, just for just to make sure thing works. Okay, you don't need to, probably you don't need to do this, but it will simplify my code later on. Okay, all right, so that's the input. Let's say now let's write the code. Okay, so I would do this. I would start from the first task, view the last task, and then I want to compute vi. Okay, so let's create vi. So you can have smaller variable with smaller caps. Okay, let's say 0 equals 0. Okay, now to compute vi, there are two ways you can do it, right? So either two choices, take leave the ith request out. So choice 1. So in that case, you get vi minus 1, right? So that would be easy. So I would initialize vi to be vi minus 1 right away, and then I'll check if the next value that I get by taking the ith element is better than this value or not. So let's say if wi plus vi pi is larger than vi, then I would say vi equals wi pi. So that's pretty much the code. Okay, so that's the max thing that I mentioned. But you need pi, right? So that to do this you need pi. But let's say we know what pi is. So and then we would just output vn. So that's the best value. Okay, so how can we build pi? Okay, so we can do this. We can just write pi pi. Okay, let's write a function that phi pi index. Okay, then just do that. Okay. Okay, so I would basically search for the first value of something that comes before my value, right? So while let's say the answer is j, while j is larger than 0, if the ending time of j is less than or equal to the starting time of I, then I just return j. Otherwise, j minus minus. I look at the previous one. Okay, and then return j. I'll stop at 0, right? And then I just return. Okay. And here v0 would be used if I have no previous task at all. Okay. Right. So that's the code. Let's see if it works. Oh, okay. I haven't declared p. Okay, so let's run. Let's try the example input. Copy and paste. Doesn't work. Let me try it again. Copy. Let's try to run it. Okay, it's the answer 4. Okay, that should be okay. Let's try this as well. So the task actually asks you to output the set. but we will get the value first. Okay, so that's the maximum value of the request, and then you need to output the actual request. Okay, how can we figure out the actual request? Okay, we need to basically remember the choice that we made. Okay, so that's a recurrence, and if we make this choice, right, then we know that we need to build a set of requests that we accept. So if we take this choice, then we know that, okay, I'll just look at the solution from the previous one, right? But if you take this, then you need to somehow remember that this is the previous value that you take from. Okay, so let me try to do that to keep my choice in another variable. So let's say let's call it variable b. Okay, so bi would be -1 first. If bi is -1, it says like I'll just ignore this element, this request. But in this case, I need to recall bi equals pi. So let's say I'm take this, and then the previous best solution that I should look at is this pi. Okay, so in order to build up the find the solution that I have, I need to work with this value bi. Okay, so let's have a vector that give the solution for us. Okay, so include. So I need to work backward. Okay, so it's called, this is the last element that I need to look at. Okay, and then I need yk is at least 0. Okay, and then I check if bk equals -1. In that case, I know that I'll ignore this thing, right? So then I say k minus minus, else I know that I take the kth guy, so I say accepted the pushback k, right? And then I need to move k to the previous one, so then I can say bk, because bk keeps the index of the previous task that you can get, right? So this is stuff like that, and then with this you can just print it out, and then print. I need to print the whole thing, right? Okay, then I need to output cout, and then cout. Okay, so let's do this. Let's see if it works. So let's try this value. Okay, looks like it's working. Okay, so let's try to submit it. Yeah, it passed. Okay, so that's how you work on the task from start to finish. Okay, so let me give you a quick review. So so this is the main thing. Okay, you need to figure out this first. Okay, if you don't have this, then pretty much you don't have anything. Okay, but the idea is like okay, to solve dynamic programming tasks, you may have to come up with recurrence. But to do that, you need to look at subproblem. Okay, so you need to look at the problem and see the problem structures to come up with the subproblem and then formulate the recurrence. When you have the recurrence, you need to do this, and you need to think about the boundary condition, and then you need to implement. There are two ways: do the for loop or do the memoization. Okay, this is like write recursive function with the cache. Save the old value. Okay, and if you need to build solution, you need to output solution, not just the values. So previously, up to this point, we just compute the value, right? The optimum value. But if you need to output the actual solution that give you that value, so you need to keep track of the choices. Okay, and then work backward. Usually you need to work backward to come up with to rebuild the solution, reconstruct the solution back. Okay, so this is where in the code previously I used variable b instead of just the recurrence. Okay, so the recurrence is this, and when you keep the variable b to sort of like help you when you construct the solution later on. Okay, so and then you need to do it backward. Okay, so that's the quick review of dynamic programming. I hope you can work on the task now. I'm gonna give you a review on task elephant in class. Okay, it's not that hard, but you need to think about it. Okay, all right, have fun solving the problems. Next week again we'll look at more complex dynamic programming tasks. All right,